This is a short primer about memory in Cocoa. To understand how memory in Cocoa works, we will first make a quick detour to tell you about traditional memory management, so you will understand how and why Objective-C and Cocoa do things slightly differently. In traditional memory management, when you have one block of memory, for example an object, and another second block of memory, so a second object for example, who both share access to a third block of memory, you have one problem. There are only two operations in traditional memory management: creating a block of memory or creating an object and deleting it again. So what happens when the right object doesn't need the shared object anymore? Well, since it does not really know whether the shared object is shared or not, it will simply delete the block of memory, which is a problem for our bottom object, which still thinks that it still has access to that shared object. So, what's a good solution for that? The solution is called reference counting. Reference counting is there to ensure that not only will memory be freed, deleted when it is no longer needed, but actually memory will also stay available until the last person or the last object who needs it has done whatever it needs to do with it. So how does this work? Well, we have our two objects again, and one of them references a third object. Now that third object keeps an internal counter who, or rather how many other objects are interested in using it. So to maintain this counter, the bottom object, when it was first told about the existence of the top object, or maybe even when it created the object, called retain on the top object. Retain simply increments the counter of how many people have a reference to this object by 1. So when the right object is told about the object it shares with the bottom object, it also retains this top object. So the retain count goes up to 2. Now, by in itself, this is not very useful, but now what happens if the right object is done using the top object? Well, it releases the top object. Releasing makes the counter go down by 1. So the reference count is now 1. And while we still know that someone is using it, we also now know that we don't have the second object using the top object anymore. Now the interesting thing happens when we have the bottom object release the top object. So the bottom object no longer needs the top object, and the retain count goes down by 1 and hits 0. Now the point where the retain count would hit 0 is the point where the top object knows that nobody cares about it anymore. So it simply deletes itself. With this simple mechanism, we now know whenever an object is no longer in use, and we also always keep track of whether an object is still used by someone. However, since everyone who uses an object just calls retain or release on it once to register one's interest or give up one's interest, they do not really need to know about each other. This is very nice. Now, what other advantages does reference count have? Well, you can build object chains. Now you can traditionally build those with pointers, but it's a little easier. Since, for example, if you have one object, the top object, that is owned by someone outside and has a reference count of 1, which was achieved by calling retain in some way on that object. And now this top left object has a second object that it uses for some of its purposes. Now the second object is also retained, so it has a retain count of 1 because its owner is the left object. And now this second object also owns another object, so that one's object also has the reference count 1. Now the outside party who owns our first object does not need to know about any of the other objects. It can treat it just like any other object, and that is call retain on it to keep it around, or now call release on it to get rid of it. Let's do that. We call release on it and our object goes away. Now, right before the object deletes itself, it quickly tells any object that it owns that it doesn't really need that other object anymore. So it calls release on its object, on the right one. So the right object's reference count goes down to 0 as well, and it deletes itself, and again, right before it does that, it tells the third object that it no longer needs it. Now the third object's reference count goes down to 0, and the entire object chain is released, and the memory is available for other code in our application. And all of that because the outermost guy simply called release on our object without knowing that there were other objects involved, which went away cleanly and transparently. Now there's one downside to this reference counting object, and that's the retain circle. Now how does a retain circle look? Well, let's build another structure like we had before. We have 3 objects referencing each other. Now what happens if the bottommost object actually needs to know something about the top object? Well, you would say, we should just have it retain the top object. We do that, and the reference count of the top object goes up to 2. But now, what happens when the outer party releases the top object? Its reference count goes down by 1, not surprising, but nothing else happens. Now, since the outer party gave up its pointer to this object, there's nobody else who knows any of these 3 objects still exist. They just use up memory. So why don't they go away? Well, an object goes away when its reference count hits 0. So let's see, why doesn't the top object go away? Well, it's owned by the bottom object, so of course its reference count is 1. Why doesn't the right object go away? Well, it's owned by the top object, which has a reference count of 1, so isn't going away. And why doesn't the bottom object go away, so the top object and the right object can go away? Well, that's because the right object owns it, so it also has a reference count of 1. And this is why in Objective-C it is generally a bad idea to have a pointer that goes up the hierarchy to your owner or your owner's owner and retains it. You should simply use a weak pointer, which is a non-retaining pointer, and this problem won't occur. Of course, usually using a pointer that does not retain an object means if the other object goes away, your pointer will still think there was a valid object somewhere. And your program might crash trying to access an object that has already gone away. But in this case, this cannot happen because you know that the top object to which you have a weak pointer is actually indirectly your owner. And that's pretty much all I wanted to tell you about memory management in Cocoa. I hope it has helped clarify some things, and I hope the graphics were helpful.